And now it's problem time. Let's go, let's get it. So the first problem is going to be an Olympiad problem to get your brain up in shape, get it going. It's typical inversion problem. The next two after that will be computational problems so that you'll be warmed up and you'll have that mindset in you for inversion from that first problem and you can kill those other two problems. Let's start. Problem 1, Iran Olympiad 1996. Consider a semicircle with center O and diameter AB. A line intersects line AB at M and the semicircle at C and D such that MC is greater than MD and MB is less than MA. Suppose that the circumcircles of AOC and BOD meet at a point K other than O. Prove that MKO is equal to 90 degrees. At first, this looks like an angle chasing / radical axes problem, but it might be a bit hard to see. First of all, where are the radical axes? AOC, BOD, OK, we have OK radical axis, but how are we going to prove this perpendicular to the MK? We could show that M and the centers are collinear, but that actually is not true. If M center and the centers were collinear, it would be perpendicular to the midpoint of OK, not actually K. So that might not work so well. Although it was nice to think about it. I mean, it's okay. There's circles. You're gonna think radical axes, of course. And no, we actually are going to use radical axes. Note that BD, OK, and AC are concurrent. So let's draw that in. Okay, this might not be so. Let's draw this on the next slide. I'm going to draw the semicircle. Let's see, that's DC. A. I'm not going to draw in the circles of OAC, OBD because we actually don't even need them now when we use our inversion. And this is actually because, I forgot to draw this line here. And, okay, so before I draw in K, let's see what happens under inversion. We see that when we invert through O, some really very nice things are going to happen. OBD becomes a B prime D prime. OAC becomes line A prime C prime. But B prime D prime A prime C prime actually stay fixed if we invert through the semicircle. So let's invert through the this circle. Let's invert through that circle so that OBD becomes just line BD. OAC just becomes line AC. That's nice. That's really nice. And furthermore, K prime is actually gonna be the intersection of AC and BD because before it was the intersection of OAC and OBD and intersections are preserved. So that up here is K prime and we'll draw in K prime here. We also have to involve M over here. What's gonna happen to M? Well, M is actually gonna be a point on the circumcircle of OCD. In particular, OCD and M prime are going to be concyclic. But C and D are fixed, and so is O. Let's draw M prime over here. So we know OCD M prime is a circle. Alright, Now we have to make this one more crucial observation. First, we want to know what we want to prove in this inverted diagram. We want to show that because we want to show MKO is 90 degrees, so by that theorem 8.2 of angles, we want to show that OM prime K prime over here is 90 degrees. Or in other words, we want to show KM prime is the altitude of triangle AK prime B. Now, what is this circle going to have to do with it? But note that, remember that BC is perpendicular to AK prime because AB is the diameter. And similarly, AD is perpendicular to BK prime. So it turns out the intersection of, let's see. Oh no, we don't need the intersection. Also, note that O is the midpoint of AB. So, C is the foot here, D is the foot here, O is the midpoint. That means this circle is actually the 9-point circle of AK prime B. That's the crucial observation now. Because since the 9-point circle is a circle is uniquely defined by 3 points, and the 9-point circle passes through these 3 points, so this indeed is the 9-point circle. So now there's an easy finish. Note that the M prime is defined now to be the intersection of circle OCD, or in the other one's the 9-point circle, with AB. But by properties of the 9-point circle, we know that both the midpoint and the foot have to line the 9-point circle, but M prime obviously is not the midpoint because O is already the midpoint and O and M prime are not equal. Thus, M prime is the foot, which we wanted to prove. So thus, K prime M prime O is 90 degrees, and we are done. Let's draw a QED symbol here. Yeah, so that's a nice problem. It was pretty straightforward under inversion. So, yeah, now you got that in you. Let's continue.